So what we are going to solve is a graph question. Let's read the question first. All ancestor of a node in a directed acyclic graph. You are given a positive integer n representing the number of nodes of a directed acyclic graph. The nodes are represented or numbered from 0 to n minus 1. You are also given a 2D integer array edges where edge I is equal to from I to I denotes there is an unidirectional edge from I to I in the graph. Return a list answer where answer I is a list of ancestor of the ith node sorted in ascending order. A node U is ancestor of node V if you can reach V via a set of edges. Okay, so this is what a graph looks like. So it's a graph question. We don't have to identify whether it's a graph question or not. So now let's get straight to the point. Yes, wait, let's take this right. Okay, so now let's see what it look like. So here we have three, got a node 0, got a node 1 here, and we got a node 2 here. Okay, sorry for the bad drawing, I say bad sketching. Okay, so this is 6 and here comes a 7. Okay, so from 0 we can reach 3, we can reach 3 via 1, we can reach 5 via 3. It's all from our edges. Okay, there's a 4 node missing from, so we are getting this formation from our edges array. Okay, and here comes 2 to 7 and 4 to 6, and there's also a node from 3 to 7. Okay, so we can reach 3 via 0 and 1. So let's first see what we are having as a result. Since 0 does not have any parent node, there's an empty array as a result. 1 similarly doesn't have any parent node, and 2 also does not have any parent node, so just empty array are being returned. For 3 we can reach 0 and we can reach 1. Okay, so from 0 and 1 we can reach 3, so 3 has 0 and 1 as its parent. When it comes down to 4 we have 0. Okay, so there's an edge missing from 0. So from 4 we can reach, from 0 we can reach 4, and from 2 we can also reach 4. And what we will say from 6, let's see 6, it has the maximum number of parents. So for 6, 3 is the parent, we can see directly 3 is a parent, 4 is also a direct parent. But since 2 is a parent of 4, so it is also a parent of 6. And since 0 is also a parent of 3 and 1 is also a parent of 3, and since 3 is a parent of 6, so they also become automatically the parent of 6. So we don't have to check only the immediate parent, but we have to also check the ancestor nodes of this particular parent. So we have a great grandparent relationship of kind of that thing. So the first thing that comes to mind is if we just reverse this relationship. Okay, see, if this relationship is reversed, I have now changed the direction of this node. So instead of focusing on this node and this node, we have changed the directions from, so from now 6 we can reach 3 and 4 as they were its direct parent. So 3 and 4 will be the direct parent of 6. Now if we change the relationship for 3 also, so from 3 the array which were pointing in, we change them to out, and we have 0 and 1. So now 0 1 3 4, and similarly or 2 also, so 2 will be also. So if we just change the direction of each and every node that we are having in this graph, so that the relationship will change from to I to 2 to from. Okay, so the parent child relationship will change into child parent relationship. So we are just converting the graph into inverse of it. So we can just start a DFS from a particular node in this graph. Just from like 6 we start a DFS, we can reach 3, and from then 3 we can reach 0 and 1. So for every time when I start a DFS from a particular node in the graph, I will visit all the parent node of that node and keep a storage here. So I just create a visited array with n as a size, and whichever node I was able to visit, I will mark it as true. Just like 3 I was able to visit, and just okay, 3 I was able to visit, 0 I was able to visit, 1 was I was able to visit, 2. So all these nodes will be marked true. 5 and 7 won't be marked true because I was not able to visit them during my DFS. So now I will just push this truth relationship in my answer array. So this will become my answer for 6. So it's a pretty simple code. So I think we should come down to coding it because it's not a big question. It's an easy one. Okay, this was rated. It was rated medium. It's but easy question, I would say. Okay. Firstly, we will need a. Okay, just enter. Sometimes doesn't work. Void. Let's just say a node we have, unordered map we have. Sometimes I get this problem of spelling of this unordered map because sometimes it's confusing for me. Unordered, ORDERIED, unordered map. In this, I will have int and a vector. I like to create my graph in this way because it's pretty easy to store the relationship in a map of a vector array. And then I will also create this vector pool of type will store the visited relationship holding all the nodes that I was able to visit. Now let's, whenever I come, I just mark the particular node as true because I was able to visit it, and then for particular node I have this adjacent graph, and in that I will visit all the node that I was able to visit. Okay, if visited v is not equal to true, then just start another DFS. Okay, v comma adjacent comma related. Okay, this is pretty perfect. Now what type here? Okay, graph questions are much preferred than array questions. I think graph question much more than array questions. I will be solving quite a lot many of graph questions these days. Vector vector int. Okay, so it's just going vector vector int array. Not going to create that. I'm going to create vector int ants array because this will be ancestor array. Let's just name as ants, and what we want is a visited array. So vector pool visited, we have n node which will all be false initially. Okay, so now we can, okay. No, no, it was jumping too fast, I was just going to vector n. I need, first thing first, I need a result array, then need a graph with vector vector int result array will be there. Then I need an unordered map, ordered map spelling just ORDERED. Okay, good. And map have an int comma vector int holding the relationship down for me. Adjacent nodes. Okay, so now for vector int at the sorry, edges, go in edges and just take my edge vec 0. Okay, my keyboard is not working fine. Okay, vec fine. Okay, now I just need to change the direction of my node. So adjacent v will have what we say my node u. Okay, so now I have changed the direction of the node, and now I will be moving forward. So for int u, I will say u0 equal less than n dot u plus plus. Okay, u less than n u plus plus. I will have now my vector int ans array. Okay, vector pool of visited array. I have n node or mark false initially, and then I will start a DFS from this u node to adjacent and to adjacent. Okay, and yes, adjacent. I'm having the graph. Okay, sorry, adjacent and my visited. Right. Okay. Now there's a case that we didn't see that much. Okay, so yes, is a relation. Okay, so there's a thing that I was missing. When I will be doing this, I will also mark 6 ads with state true. So I don't want 6 as a parent node. So what I can do is whenever I push the graph and then I check for these visited nodes, I can see that 6 has been already been visited, and this node would be same to this node value because this is true. I will check 6 is equal to 6 in my visited array. If this condition holds, then I won't be pushing it to my ancestor array, and that would be the answer of this. So this edge case would be D. Edge case, what I will say, for int I is equal to 0 dot I is less than n dot I plus plus. If I is equal to u, then just continue. Don't do anything. Just continue. If visit it I is equal to true, then I want you to push and start push back my ith node. Okay, good. Now what I want to do is, in result I want to push back my ancestor. Okay, so my result dot push back and okay, good. Then I will do is just return the result. Okay, return. Let's see whether it works or not. I think this should work. Okay, just hide this screen recorder. Just run it. Spelling erase of compiler. Okay, compiler error. Int u. Okay, what's the error here? Let's see what I have done. The mistake. Why didn't you? Where I have done this error? What was? Void. Sometime what have I done? There's a mistake here. Int u. This is a comma. Listed. Okay, good, good. This unordered map int comma vector int adjacent. Okay, so what's the problem? Okay, not able to see the problem here by far. Okay, no problem here. I see, just the issue. It's the same error. I guess I will get the same error. Okay, I get the same error. Again, void dfs int u, and still it's not working. Now, what's the particular problem that I expected? Okay, line number 3. What's the problem, brother? What's the problem? Okay, why didn't you another graph listed? Let's rewrite this particular part again. Yes. Okay, void int u okay, so void dfs I have int u comma on ordered unordered map int comma vector of int, and it would be an adjacent matrix kind of relationship, and we have a vector pool, and it would be a visited. Okay, so now I think it should work. Okay, it works pretty much here. Don't know what the error was. Okay, it's now working. Let's see by submitting this. Okay, so now let's see what can be the time complexity of this. Okay, so we are going here. Let's say order of n cross this dfs, that would be n into m. So my time complexity for this would be order of, okay, just write this, order of n cross bracket n plus m plus m. Okay, that's good. So this will be the time complexity. Okay, so this is done for this question. If another approach comes down to my mind, I will just just post it. Okay.